All right, as we fire up part 2 of this part 1, unit 6 trig test preview, we are going to chat with a couple more applications here and then see what else we got left. So we got a diagram here. Earth, Mars, and the Sun. What's the distance between Mars and the Sun in this data? Now, could it be helpful? Maybe. You're like, why are you redrawing this? Because I'm going to redraw this with A, B, and C. So I can take a peek at this and go, well, hey, all right. So now I'm trying to find the distance between the Sun and Mars. So I'm looking for that. Now, am I going to be able to get that right off the bat? We'll see. No pun intended. So I do see that I have this. So I've got the sine of 169 over 224. Okay, that's the first place term. And it's a wide angle. Equals, what do I have right now? Well, all I have is side C. It's across from A here. Now, could you do this with M and E and S? You certainly could. There is nothing wrong with doing that. Just know that I like kind of working it in that same format. So let's see what C is going to be here. Mars, you're going to be, let me get out of there, 91.6 sine of 169 divided by 224, second sine. So, that's little. Very little. I'm always making sure that I always check that before I'm doing all of these, so I don't get myself into trouble here. So I'm just making sure we're going good. All right. So we're good there. So 4.5 degrees, we'll say. Then let's see what else we got here. So 180 minus the sum. Plus, I'm kind of putting that over here, 169. So 180 minus 173.5 would be 6.5. I apologize for getting right after lunch here, and sometimes, wait a minute. Hardy, what did you just do? No, that's right. Okay. So I get in there, and you're like, okay, so are we done? Well, no. Because now I've got all this. I'm still trying to find this. So my last step, I finally get to do what I'm looking to do this whole time. Sine of 169 over 224 is going to be, what do we got? Sine of 6.5 over B. All right. The moment of truth is here, 224 sine. Divided by the sine of 169. So B, and it says round to the nearest whole million miles, so we'd have 133 million miles. Which again, is that reasonable? Well, B is the second largest angle, and now looking at this, B is the second largest side. So yeah, I'd say that's definitely going to work. All right, postal airplane leaves A, flies 91 to B, drops off 61 to C, returns to A at an average rate of 300 miles per hour. How long does it take the pilot to travel from island C to island A? In other words, what's B? Round to the nearest tenth. Okay, so I have two sides in a non-corresponding angle. So back to the law of cosines we go. So we take the sum of our squares minus 2 times their product times the cosine of that angle. All right, let's see what we got here. Okay, so we need to take the square root that big old number. No need to go to a tenth. We got it. Okay. Biggest angle, biggest side. Bam. Find the values of the trig function for angle theta. All right, so again, there's theta, there's opposite, there's hypotenuse, there's adjacent. As long as I know my original three, I'm golden. So we got opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Luckily for me, none of these reduce. If they did, I would need to reduce them. But as long as that is set, we just take the inverses of those. Okay, that's not too bad. All right, the tangent of A is 5 over 12. Find the sine of A. So reminder, this is opposite over adjacent. This is opposite over hypotenuse. I need the hypotenuse. So 5 squared plus 12 squared will give me the hypotenuse squared. So the hypotenuse is 13. So sine of A will be opposite over hypotenuse. Bam. Be careful here. If cosine of A, adjacent over hypotenuse. Find the sine of B, but again, yes, that's opposite over hypotenuse normally, but it's a different angle. So let's play this game out. So here I got 9 squared minus 7 squared. Ooh, wait a minute. Before I go doing a bunch of work I don't need to, wait a second. A, B, C. Okay, so if cosine of A is adjacent over hypotenuse. Now, yes, I know, I could find this missing side, but wait a minute. If I'm looking at B, and I'm looking at opposite over hypotenuse, oh! Now, would it have been terrible if I went through and found this other side? No, but I'm going to be kicking myself at the end when I do this. So I would say draw pictures first on these to make sure, especially if the angles are different, to make sure you're not doing more work than you need to. That was pretty slick. All right, positive and negative coterminal. Reminder on coterminal. 360 degrees or 2 pi, depending on if you're in radians or not. If you are in radians, you must stay in radians. So I need to know what 2 pi is in sixths. Multiplied by 6, okay. So 12 pi over 6 is what I want to deal with when I'm doing my positive and my negative. 7 plus 12 is 19 pi over 6. And 7 minus 12 is negative 5 pi over 6. That's all we're doing. That's going to be the hard part of this. Like, if there was actually a hard part to this, okay? Here, with degrees, well, degrees we love. Uh-oh. How did that just... Ugh. I'm working it too hard. Subtract. Add. You're like, that's it? As long as your positive is positive and your negative is negative, that's it. That's the end. Not bad. Not bad. Here comes the end. All right, let's see what we got. Rewrite the degree measure in radian and the radian measure in degrees. To make the pi go away, the pi has to be in the denominator. 7 times 180 divided by 12. Make sure to keep your degrees on it. If I need degrees, then I need to go to radians. The degrees go in the denominator. Say bye-bye. Do not give me a decimal. Do not forget that the pi is there. Little things like that are wonderful things. Okay. Exact value of the trig function. Remember, adjacent and opposite. So I need the hypotenuse. So 20 squared plus 21 squared equals the hypotenuse squared. And again, remember, this is going to come out positive. Whoops, no. What are we doing? Here we go. 29. So once I'm here, okay, opposite over hypotenuse, take the signs with. Adjacent over hypotenuse, opposite over adjacent. And we keep rolling. Don't let this mess you up with a 0. That's not a big deal. Okay? 0 squared plus negative 3 squared equals my hypotenuse squared. 0 plus 9. My hypotenuse is 3. So, okay. Opposite over hypotenuse. Reduce it. Adjacent over hypotenuse. Reduce it. Don't leave that fraction. I'm going to wonder. Opposite over adjacent. Don't just leave that either. Division by 0 is undefined. I've got to know that you know the difference between those two. All right. And almost to the end. Sketch the angle and find the reference. All right, so 0, 90, 180, 270. I need another 15 degrees on this. Now, we've talked about different ways you can tackle this. If I just want to tackle the 15 degrees here, I line up my protractor with the last axis I'm messing with. There's my 15. And I can go this route. You could say, hey, 180, 285 minus 180 is 105. And I also could have set this up and gone to the 105 mark right here between 110 and 100 and gotten in the exact same place. You've got to show the arrow. Make sure it's going the correct way. If it's positive, it is counterclockwise. And the reference angle, oh, be careful, is the nearest x-axis. Don't come back here. 360 minus 285 is 75 degrees, and it's always positive. Always back to the x-axis. Okay? Ooh, 14 pi over 3. Okay. I want to wrap my head around this one. No, Hardy. Now, I did that as a reminder. If you're doing this and you want to know degrees, you actually have to type it because that's not helping me. Now, be careful if you go this route because you're like, okay, 90, 180, 270, 360, 450, 540, 630, 720, 810. I need another 30 degrees from here. So again, depending on the way that you want to go, if I just want the 30 from here, that's cool. I get that drawn in. If you came back over at this one, when you're at 720, you'd have just done a 120 degree angle. As you can see, it's the same from where I was going here. But again, the reference nearest, but be careful. What do you mean, Hardy? Don't tell me that your reference angle is 60 degrees. Don't do that. We're in radians. So if you're thinking 60, that's not really what it is. You're doing it times pi over 180. And hopefully at this point we know 60 degrees is just pi over 3. Okay? Radian start, radian end, people. All right, last ones. Exact value of the trig function. Use special right triangles. So, let's see here. 7 times 180 divided by 3. Okay, this tangent of 420. So my first job, I need to know my reference angle. Now, I could have probably just made this easier by looking at this over 3 and said, hey, it's going to be pi over 3. Because doing it this way, I'm going to say my reference angle is 60 degrees. So if you can look at it, this is easier. It's pi, 2 pi, so it would be 3 pi over 3, 6 pi over 3. When I'm thinking about my nearest x-axis, so I can do it visually this way, or if I go to degrees, I just got to make sure I get it back. So I look, and I'm like, okay, so 30, 60, 90, 1, square root of 3, 2. I don't need the x's in this point. Those are my exact values. And so if I'm looking at 60, it's opposite over adjacent. And then I just got to think for a minute. I'm like, okay, what quadrant am I in? So 420, 90, 180, 270, 360. So 420, I'm in quadrant 1. Everything's positive in quadrant 1. So that's how I know that it's going to be positive versus negative. Okay, again, the exact value means no decimals. Don't even think about it. Silly people. All right. So my reference here is going to be 45. Well, Hardy, what if I don't know? What if I don't know 720 is the closest? Okay, you could take 675 and keep minusing 360, but remember, your reference angle is never negative. So, I mean, if you keep that part straight, you can make this work. So I'm like, all right, 45 degree reference, 45, 90. I want the cosine of 45. So the cosine is going to be 1 over the square root of 2. Pop that to the top. Eliminate it here. 675. All right, let's kind of do it over here again. 360. Let's just do our own. 90, 180, 270, 360, 450, 540, 630. 675, we're in quadrant 4 of all students take calculus. We're in the cosine quadrant. That's it. Okay? I did a whole heaping lot of talking as I was going through here. So again, can you smoothly work through these? If you've done the practice, probably. If you haven't done the practice yet at this point, do it. Okay? Because you need to have it done on test day for me to be able to see what's going on with stuff. If you have questions, let me know right away so we can get you set. We'll see you next time.